Well, today's theme is parallelograms. We're going to be talking about parallelograms and properties of parallelograms. It's pretty important that you know the properties of parallelograms. There are going to be several of them, and that you memorize these properties because we're going to use them to set up and solve equations. So first off, let's talk about what a parallelogram is. A parallelogram is a quadrilateral, so it has four sides. And by definition, the opposite sides of a parallelogram are parallel. Both pairs of opposite sides are. Remember, the little arrow symbols indicate parallel sides, not necessarily congruent sides, but parallel sides. That's what that little arrow symbol represents. So the first property of parallelograms that we have by definition is that both pairs of opposite sides are parallel. That R was terrible. Okay, so that's our first property. Both pairs of opposite sides are parallel. If a shape has both pairs of opposite sides parallel and it's a quadrilateral, then that is a parallelogram. That's what that means. Now, what else can we conclude about parallelograms? Okay, additional properties, and these are from our theorems in our book, and they're in your notes as well. Opposite sides are also congruent. Okay, opposite sides are congruent. Both pairs of opposite sides. So not only both pairs of opposite sides are parallel, both pairs of opposite sides are also congruent. It's nice. We also have both pairs of opposite angles are congruent. Now that's a little bit different, but again, we're looking at, if we look at the picture here, that angle Q and S are congruent, and angle R and angle P are congruent if that's a parallelogram. So, properties of parallelograms so far: both pairs of opposite sides parallel, both pairs of opposite sides congruent, both pairs of opposite angles congruent. How are we going to use those facts? Like we do all the time, we're going to use it to set up and solve equations. And really, the only thing you can do to mess this up is if you match up the wrong sides, if you try to match up a side with an angle, which doesn't make any sense. But sometimes I've noticed in the homework that people tend to rush or not really think about what they're doing. They just see the equation there and they start throwing numbers together. If you slow down and think about this stuff, it's going to be pretty obvious what goes with what and what is equal to what. Here I have the x plus 4, which is the length of a side. I know it's a parallelogram because the red marks here tell me that the opposite sides are parallel. The triangles do. And so I have to compare this side, x plus 4, to the opposite side, which is 12. And they have to be congruent. So we simply get the equation x plus 4 equals 12. Subtract the 4, x is 8. For the y's, that's an angle. And we also have the opposite angle. Clearly, y equals 65 degrees because opposite angles have to be congruent. And literally, a lot of the work is that simple. Number 1 here, problem 1, it says find FG in the measure of angle G. FG is this opposite side, must be congruent to the opposite side. So FG equals 8. And the measure of angle G, again, being the opposite angle from 60, these angles must be congruent, has to equal 60 degrees. Now, I'm going to let you, in the Edpuzzle question for the first question today, find the values of x and y that go with this equation. Now that you've gone ahead and done that, let's go ahead and just work through that to check to make sure if you got the right answers, you know. But it's pretty easy. 18 equals y plus 3, so y is 15. And 2x equals 50, so x is 25. So hopefully you got both of those right. Additional properties of parallelograms. Consecutive angles theorem. The opposite angles are congruent. The consecutive angles, because the sides are parallel, and let me kind of draw this out for you real quick, but because I have parallel sides here, and I have a transversal, I know that the consecutive angles are not congruent, but they are supplementary. Those are consecutive interior angles. So consecutive interior angles are supplementary. So any pair of consecutive angles in a parallelogram have to be supplementary, because no matter where I set up my angles, okay, no matter which two angles I pick, let's pick this X and this Y, I've got two parallel lines because it's a parallelogram and a transversal, and again, these are consecutive interior angles. So no matter what, the consecutive interior angles are supplementary. They always add up to 180. That's kind of neat. The last one, which isn't quite as obvious either, is the diagonals bisect each other. And I'm not going to go through the proof of this, but it is important to note, again, the diagonals are not congruent necessarily. In fact, in most parallelograms, the diagonals are not congruent. They are very, very different. I can draw that something for you real quick as an example. Here we go. So if I draw in my diagonals here, the purple diagonal here is very clearly shorter than the green diagonal. The green diagonal is much longer. So the diagonals are not congruent, but they bisect each other. And let's, again, talk about what that means. The word bisect means cut in half, bisect. By, to, sect, cut, okay? So that means at this point where the diagonals intersect, this point right here is the midpoint for both diagonals. In other words, these two sections have the same length, and these two sections have the same length. Again, the diagonals are not necessarily, all X and Y are not the same, but that point where the diagonals intersect is the midpoint for both diagonals. They bisect each other. As you can probably imagine, the proof has to do with congruent triangles. So if that's the case, those are the cases we have now. The diagonals bisect each other, consecutive angles are supplementary. Let's answer this question. It says, find the measure of angle BCD when the measure of angle ADC is 110. Let me just help you a little bit. ADC is this angle right here, okay? It wants you to find the measure of angle BCD, which is right here. And that's where we're going to throw our question in number 2 today. Now that we've done that, let's go ahead. Hopefully you came up with the correct answer there. Not too tough at 70. How about this one? What is the measure of angle ADC when it's twice the measure of angle DAB? Okay, DAB being this angle right here. Well, they're consecutive angles and one is twice the other. So if ADC is twice the measure of angle DAB, let's call the measure of angle DAB X. ACD is twice that, so that's 2X. And we simply get 2X plus X equals 180. They're consecutive, they must be supplementary. So 3X equals 180, so X is 60. So my angles are 60 and 120. So properties of parallelograms, just to summarize. You might want to make sure this winds up in your notes. Opposite sides parallel. opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and diagonals bisect each other. Those are my properties of parallelograms. You are definitely responsible for knowing those properties and being able to use them. We'll see you in class.